Hello, this video explains Granger causality test in Stata. So if you ask the question, the chicken and eggs, which came first? And that can be tested using Granger causality test. So the idea about Granger causality test or Granger causality is that if the last values of x help to predict the current values of y in a forecast form from the last values of both x and y, then one can say that x causes y. So the implementation is that first we just regress x on the log x and log y. So if the coefficients of log y are significant as a group, then y causes x. And so Thurman and Fisher applied that to the eggs and the chicken question. So they regress x on the log x and log chicken. And if the coefficient of log chicken are significant as a group, then chicken causes x. So here is the results of their analysis. I do not have access to the data to replicate that, but this is the result of the analysis. So the first hypothesis is that chicken do not Granger cause x. So that was the main hypothesis. So the first one, chicken do not Granger cause x. And how do we know whether the hypothesis was supported or not supported? By looking at the p-values, as we all know. So the p-value of log 1 to log 4 were not less than 0.05. In other words, chicken do not Granger cause x. So we cannot reject the null hypothesis. So the second question then is, did the egg come first? So then you also make look at the log values of eggs on chicken. So that is the null hypothesis. Eggs do not Granger cause chicken. So then again we observe the coefficient, okay, or the p-values of the log values of x. So as you can see, from log 2 to log 4, they are statistically significant as the p-value are less than 0.05. Then they concluded that the eggs came first and then led to chicken. We applied the same in our articles. This is the article published in First Online 2019. And the question was, did credit risk cause operating costs to go up? So we were much interested in the fact that the microfinance industry has low credit risk compared to traditional banking. And our argument was that they have focused so much on credit risk to the extent that operating costs were going high. And then we did the Granger causality test to see whether that was the case as part of the analysis. To do Granger causality test, first you have to declare your data as time series. Second, you have to run the VASO test to determine number of logs. And third, you have to run the VAR model, the vector autoregressive model. And third, you then run the Granger causality test. So let's get to Stata using our own research to illustrate how to do it. So in Stata, as we know, the first step is to declare your data as time series. So our data is panel data, and then first we have to collapse it and make it time series data. So to do that, you have to preserve the data in order to keep it original, and then run the portion of the data that I want to use. So by using the collapse option, I look at the variables that I'm interested in. So next, we have to run the VASO model to determine the number of logs. And then finally, third, we run the vector autoregressive model. And then after that, determine using the number of lags. So after running the VASO model, we saw that the optimal number of lags is 4, and we use that to run the VAR model. And after that, we run the Granger test. So let's just do all of that and see the result. So this is running in Stata. So let's interpret the result here. So quickly, we look at first, declare the data time series. So you see here from 1998 to 2015. And then number of lags and lag selection. So then we look at the one with the optimal lag is the one with the asterisk. So we see that using all of these ways of determining number of lags, all of them are consistent. All of these say that, well, number of lags should be 4. So because we have the asterisk here. So then we move next to use lag 1 to 4 for our model, our VAR model. And after that, we run the, so here in the VAR model, we can see this is the first equation where we say that, well, portfolio risk significant, the lag values of portfolio risk are determining. So as we explain, the lag values of the dependent variable as well as the lag values of the independent variable. So here we can see the lag 3, the third lag of portfolio at risk seem to be significant at 10%. And but we also look at the equation where portfolio at risk is the dependent variable. And then we are interested in the lag values of the operating cost. And here we see they are not significant. So we see that in a way, the lag values of operating cost, portfolio at risk, at least one of them seem to be significant. And that is a weak finding. But then we proceed to look at the Granger causality test. And the command is var Granger. And here is a Granger causality test while test. And here we are interested in the joint effect. So here, if we look at the equation for operating cost, we see the joint effect of the lags of portfolio at risk are significant at 10%. So we conclude that it is really risk that is driving the operating cost to go up. And that was our conclusion, even though it's a weak findings here. So that is how we determine or test Granger causality test in Stata to determine whether one variable is the one causing the other. See you in the next video.